Good morning children. Hope you all are fine. So in this class we are going to see a new topic. The topic is some basic concepts of chemistry 2. I hope already you have learned some basic concept of chemistry 1 in your 6th standard, isn't it? Right. Before we enter into this topic, you should know some important definitions, that is fundamental terms you should remember children. Then only you can get inside this lesson, get into this lesson. Okay. So what are the fundamental things? The first one is about matter. What do you mean by matter? Matter is anything which occupies space and has weight. That is called matter. Right? Examples under already I told you so many times, you know very well. Right? So next we can move to atom. What is atom? An atom is the smallest, that is minute particle which take part in the chemical reaction. Right. Next one is element. An element is a pure substance that cannot be decomposed into simpler substances by chemical methods. Okay. Right. And also one thing you have to remember, an element is made up of only one kind of atom. Okay, an element is made up of only one kind of atoms. Right. Next one is about molecule. Molecule means group of atoms bonded together to form molecule. For example, water is a molecule because hydrogen and oxygen combines to form the water, isn't it? So, group of atoms bonded together to form a molecule. Then what is meant by compound? A compound is composed of two or more different substances. For example, different elements. For example, water is a compound. Sodium chloride is a compound. How? Because what is composed of hydrogen element and oxygen element, isn't it? At the same time, sodium chloride is sodium when it is combined with chlorine to form the compound sodium chloride. So compound is composed of two or more different elements, right? Next one is about ions. Ions are, that is atoms or group of atoms, they have some charge. Positive charge or negative charge are called ions. We can classify the ions into two, that is cation as well as anion. What is the difference between cation and anion? If you take cation, cation is a positively charged. At the same time, anion is negatively charged. Both cation and anion, both are ions only. They have opposite electrical charges and they get attracted to each other, right? Next one is about atomic number and mass number. Both the terms are very important for this lesson. So, what is atomic number? The number of protons which are present in the nucleus of an atom are called the atomic number. And what do you mean by mass number? The total number of protons as well as neutrons present in the nucleus of an atom is called mass number. So, these terms and all you should familiarize children, then only it's very easy. Okay, you can learn the remaining things in easy way. Right. So first let me start with Dalton's atomic theory. John Dalton is famous for this atomic theory. He is well known for this atomic theory. He was a famous physicist, chemist and meteorologist. Okay, he is well known for this atomic theory. According to John Dalton, matter is made up of very small indivisible particle called atom. This is John Dalton's atomic theory. Okay, so according to him, matter is composed of very small indivisible particle called atom. What is the meaning for indivisible? Indivisible means cannot be divided, right? Atoms can neither be created nor can be destroyed during chemical reaction. This is also his theory only, that is Dalton's theory, right? All the atoms of the given element are identical in all respect. Identical in the sense same. Okay, identical in the sense same. That is its size, shape, mass, everything. Atoms of different elements are different in nature. These are the Dalton's atomic theory. It's very important. The main thing what you have to remember is matter is composed of very small indivisible particle called atom. Atoms cannot be created or destroyed during chemical reaction. Okay, you cannot create atom at the same time you cannot destroy the atom. Right. Next we can move to law of chemical combination. Some of the scientists like Lavoisier, John Dalton and other scientists, they formulate certain laws. Okay. So these laws are called the laws of chemical combination. 5 laws will come under laws of chemical combination. What are the 5 laws? First one is law of conservation of mass. Second one is law of constant proportion. Third one is law of multiple proportion. Fourth one is law of reciprocal proportion. And the last one is Gay-Lussac's law. So in this lesson we are going to learn about these laws based on the concept also. Right? First let me go into the law of conservation of mass. This law is given by Lavoisier. Okay. Who proposed law of conservation of mass? Is a one more question. Lavoisier proposed law of conservation of mass. According to this law, matter can neither be created nor can be destroyed during chemical reactions. Okay. At the same time, according to Lavoisier, the total mass of the reactants are always equal to the total mass of the product. Let me see one example. First, carbon, when it is combined, look at the board. Carbon, when it is combined with oxygen, it forms a compound carbon dioxide. What is the symbol for carbon? C. For oxygen, O2. Okay. So both react to form a compound carbon dioxide. This carbon and oxygen both are reactants, whereas the product we got that is compound. Carbon dioxide is nothing but the product. This left hand side is given carbon as well as oxygen. These are reactants, and right hand side what you are getting, that is the product. Okay. So carbon, what is the mass number of carbon? The mass number of carbon is 12, and for mass number of oxygen is 16. See here how many oxygen atoms are there? 2 oxygen atoms. So we have to multiply 2 with that particular mass number. So 2 into 16. Both react to give carbon dioxide. So what is the value for carbon? Mass number 12. For oxygen 2 into 16. Okay. Now 12 grams of carbon plus 32 grams of oxygen combines to get 44 grams of carbon dioxide. Here you have to add. That is 12 grams carbon value is given, mass number, plus you are getting for oxygen 32. So 32 plus 12 you will be getting 44 grams. Okay. So this 44 gram is the reactant value. Here this 44 gram is the product value. So what do you understand from this? The mass of the reactants are always equal to the mass of the product. Okay. So these two are reactants. Carbon and oxygen are reactants and carbon dioxide is the product. So reactants are always equal to product. This is law of conservation of mass. One more example we can see. Look at the question. 100.08 gram of calcium carbonate on heating gave 44 gram of carbon dioxide and 56.08 gram of calcium oxide. The question is, show that these observations are in agreement with the law of conservation of mass. Okay. So what we have to do, the solution is, first we have to write reactant 1 plus reactant 2 gives the product, because we have 2 reactants here. One is the carbon dioxide and another one is the calcium oxide. Calcium oxide and carbon dioxide are reactants. Both react to form the compound calcium carbonate. This is the product. Okay. So first step what you have to write? Reactant 1 plus reactant 2 give the product. Here reactant 2 is carbon dioxide and the product is calcium carbonate. Okay, so calcium oxide, when it reacts with carbon dioxide to form the product calcium carbonate. This is the second step, right? Next we have to write the symbol. The formula you have to write now. What is the formula for calcium oxide? CaO. What is the formula for carbon dioxide? CO2. Here you have to write in word form carbon dioxide. Okay. Here you have to mention the formula. Both react to form calcium carbonate. This is the third step. CaO is calcium oxide. It is the reactant 1. Carbon dioxide is the reactant 2, and both react to form the product calcium carbonate. This is the product. Okay. So now we have to mention the value. Value is already given in the question itself. What is the value given for calcium oxide? The value is for calcium oxide 56.08 gram. Already it is given in the question. So put the value here 56.08. What is the value given for carbon dioxide? 44 gram. Plus 44 gram gives calcium carbonate. What is the value they have given? 100.08 gram. So that also you have to mention, right? So next you have to separate the reactant as well as product. First you have to mention the mass of the reactant. Already I told you these two are the reactant. This is reactant 1 and this is reactant 2. That is the product, isn't it? First you have to mention the reactant, mass of the reactant. What are the reactants here? Calcium oxide as well as carbon dioxide, both are reactants, isn't it? So you have to mention it inside the bracket. Next you have to mention the values of the reactant. 56.08 plus 44 gram. Both, if you add these two reactants, what value you will be getting? You will be getting 100.08 gram. Just you add these two, okay, you will be getting 100.08 gram. Next we have to mention the mass of the product. So now we know the mass of the reactant. Next what we have to do? We have to identify the mass of the product, isn't it? So mass of the product is calcium carbonate. Already the value is given in the question itself. See the reactant value as well as the product value. The total mass of the reactants are always equal to the total mass of the product. This is the reactant value, this is the product value. Both the values are equal. Hence, law of conservation of masses proved. Got it, children? Understood? Right? Shall we move to the next one? Good. So next we can move to law of constant proportion. This law is given by Proust. Okay. Law of conservation of mass is given by Lavoisier. It's a very important one mark question. Law of constant proportion is given by Proust. Okay. Here this law states that all chemical compounds are formed to have constant composition irrespective of their method of preparation or sources. Once again I repeat. Law of constant proportion states that all chemical compounds are formed to have constant composition irrespective of their method of preparation or sources. For example, we know very well water is obtained from different sources like seawater, river water, well water, pond water, underground water, etc. Okay, whatever it may be, water is composed of two elements, hydrogen and oxygen, in the ratio 1:8 by mass, isn't it? Here, the method of preparation may be different, but at the same time, the composition will never change. It will be in the fixed ratio. Okay. Hence, this law of constant proportion is otherwise known as law of definite proportion. Based on this, we are going to see one sample problem. The question is, look at the question. 1.80 gram of a certain metal burnt in oxygen gave 3 gram of its oxide. If a metal is burnt, its oxide level increases. It increases the oxide. Okay. 1.50 gram of the same metal heated in steam gave 2.50 gram of its oxide. Show that these results illustrate the law of constant proportion. Okay, so already value is given. We have to illustrate the law of constant proportion. Right? Now, solution. So, in the first sample of oxide, two samples are given, isn't it? So, first, in the first sample, what is the weight of the metal? The weight of the metal is 1.80 gram. It is given in the question itself. Next one, weight of oxygen. So, when a metal is burnt in air, its mass increases, isn't it? So, the oxide range is 3. And what is the weight of the metal? Weight of the metal is 1.80 gram. So, if you subtract these two, you will be getting the weight of the metal. Okay. So, that is 1.2 gram. Weight of oxygen you will get. If you subtract these two, you will be getting the weight of oxygen. So, the weight of oxygen is 1.2 gram. So, next step what you have to do? What is the weight of the metal? The weight of the metal is 1.80 gram. Isn't it? What is the weight of the oxygen? Already we got one answer. That is 1.2 gram. If you divide these two, you will be getting the first answer. Okay. So, if you ordinary division only, 180 divided by 12, you will be getting 15. Just put the decimal 1 point. So, you will be getting 1.5 gram. So, for first sample, we got the answer. In the same manner, we have to do the second sample also. In the second sample, weight of the metal, it is given 1.50 gram in the question. Now, weight of the oxygen we have to find out. So, if this metal is but this 1.5 gram is burnt in air, we get 2.50 grams of oxide. So, we have to subtract this oxide from the weight of the metal. So, you will be getting the oxygen weight now. So, if you subtract these two, you will be getting 1 gram. Okay. So, finally, the same manner in the first sample what we did, the same steps we have to follow. Weight of the metal divided by weight of oxygen. Weight of the metal is 1.50 gram. And what is the weight of oxygen? It is 1. If you divide these two, you will be getting 1.5 grams. Okay. So, hence the law of constant proportion or law of definite proportion is proved. Got it, children? Right. Next, we can move to law of multiple proportion. This law is given by John Dalton. This law states that when one element combines with another element, it forms two or more different compounds. Okay. Here the mass of one element, when it combines with the masses of other, it forms a simple ratio. This is the concept behind the law of multiple proportion. Once again I repeat, when one element combines with the other element to form two or more different compounds. Here the mass of one element when combines with a constant mass of the other, it forms a simple ratio. Based on this, we are going to do this one. Okay. Already I told you when one element combines with the other element, it forms two or more compound will be formed, isn't it? So, when you take hydrogen and oxygen, hydrogen when it reacts with oxygen, it forms two compounds. One is water, another one is hydrogen peroxide. Okay. So, hydrogen when it reacts with oxygen gives water. This is the first product, first compound. Okay. So, here we have to substitute the hydrogen mass number. What is the mass number of hydrogen? The mass number of hydrogen is 1. How many atoms? What is the formula for hydrogen? H2. 2 atoms of hydrogen. So, we have to multiply the mass number with that particular atom. Okay. So, 2 grams. Next, hydrogen when it reacts with half O2. What is the mass number of oxygen? The mass number of oxygen is 16. We have to take as it is because it combines with half molecules of oxygen. Okay. Both react to give the compound water. When you add these two hydrogen value as well as oxygen mass value, you will be getting the compound, that water compound value. So, 2 gram plus 16 gram gives 18 gram. Okay, this is the first product. Second one, hydrogen when it reacts with oxygen, it forms another compound, hydrogen peroxide. Okay. So H2 plus O2 gives H2O2. H2O means water. At the same time, if the compound H2O2, it mentions hydrogen peroxide. Hydrogen peroxide. Okay. So here the same mass value we have to substitute here 2 grams. But here 32 grams. Why? Because oxygen, 2 oxygen atoms are here. So we have to multiply the mass number with 2. So you will be getting 32 grams. Both combines to form the hydrogen peroxide. So 2 plus 32 you will be getting 34 grams. Okay. So from these two samples, from these two compounds, we came to understand that the masses of oxygen, okay, the masses of oxygen, the masses of oxygen, that is 16 gram and 32 gram. Okay, masses of oxygen 16 gram and 32 gram. It combines with the, so the masses of oxygen 16 gram and 32 gram both combines with the fixed mass of hydrogen 2 gram. Okay, and hence it shows the, what is this? It bears a simple ratio to one another, isn't it? So 16 is to 32. If you strike it out, you will be getting 1 is to 2. This is the concept behind the law of multiple proportion. Understood, children? Right. Next, we can move to the Avogadro's law or Avogadro's hypothesis. So Avogadro was an Italian scientist. He proposed this law. Okay, Avogadro's law. This law states that equal volumes of all gases under same conditions of temperature and pressure contains equal number of molecules. Okay, once again I repeat, equal volumes of all gases, any gases at same conditions of temperature and pressure contain equal number of particles. Okay, for example, look at these balloons. Look at these balloons. You just assume this balloon is filled with oxygen gas. Okay. This balloon is filled with ammonia. This ammonia gas. This balloon is filled with hydrogen gas. And this balloon is filled with nitrogen gas. Okay. So all these balloons contain equal volume of gases. Equal volumes of gases are filled in this 4 balloons. Okay. At the same temperature and pressure, these balloons, these gases, that is hydrogen gas, oxygen gas, nitrogen gas, ammonia, it contains the same number of molecules only. Okay, for all the balloons, it contains the same number of particles at the same temperature and pressure. Under the same conditions of temperature and pressure, these balloons contain equal volumes of equal number of molecules present in each of this balloon. Okay, once again I will inform you. Avogadro's law states that equal volumes of all gases under same conditions of temperature and pressure contain equal number of particles. Okay, so these balloons are filled with gases. For example, hydrogen. This is ammonia gas, nitrogen gas, oxygen gas and hydrogen gas. Okay, so equal volumes of gas is filled in these balloons. At the particular temperature, same conditions of temperature and pressure, all these balloons contain equal number of molecules. Equal molecules are present in all these balloons. Okay, so this is the concept behind the Avogadro's law. Okay, this Avogadro's law is also very important. When you go to higher classes, you will learn many things about this Avogadro's law. Okay, so what are the things we have discussed so far? We have discussed about Dalton's atomic theory, followed by laws of chemical combinations. In that we have discussed about law of conservation of mass, law of constant proportion, law of multiple proportion, finally Avogadro's law. 2 more laws are there. In the next video we will discuss about those laws. Okay, so in the meantime, today you will get your assignment, children. Maintain science. So for physics, chemistry as well as for biology, use long size unruled notebook. Presentation is very important. Keep all these points in your mind and write the classwork. Use good pen. Okay, that is very important. Presentation is very important. You will get marks for the presentation also. The remaining things we will see in the next video. In the meantime, you go through what are the contents we have discussed so far. Okay children, thank you.